Good morning, boys and girls. I want to welcome you to another class of chemistry, and I want to believe that we are getting along well. This morning, we'll be starting a new topic on carbon. We'll be looking at carbon, allotropes of carbon. I pray as you follow, God will give you understanding in Jesus' name. Now, I want to believe you know the element carbon. Carbon is the sixth element with the symbol C. And I believe you know the structure you are seeing. 6 electrons, 6 neutrons, 6 protons. So I don't need to talk much on this. It's what you know already. Carbon is a non-metal. You know, we have metals, we have non-metals, we have metalloids. So carbon is a non-metal. Get that right. The symbol is C, and it's been known for long, very long. Those days as charcoal, as soot, and diamond. And I want to know that carbon is a very unique element. Of all the over 100 elements discovered so far, carbon is very unique. And the only reason for this uniqueness of carbon is because of its ability to catenate. That is, carbon can form long carbon-to-carbon straight chain compounds and branched chain compounds. It can link with another carbon atom and then form a very long chain. Can contain about 50 carbon atoms joined together, thousands joined together. And that's why it is very unique. Other elements cannot do this. Then apart from carbon existing as charcoal, as diamond, soot, etc., carbon can also occur in combined forms or combined states. That means in combination with other elements, such as we have in petroleum, we have in wood, gases, like carbon 4 oxide, carbon 2 oxide. We can also see carbon in mineral deposits, such as the triisocarbonate 4, etc., like the Na2CO3, K2CO3, MgCO3, and so on like that. Now, let's look at allotropy. What do we mean by allotropy? Allotropy is the existence of an element in two or more different forms in the same physical state. When an element can exist in different forms in the same physical state, then that is allotropy. Let me give you this instance. When you look at water, water can exist as steam, that is gaseous state, as liquid, as water, that is liquid state, and as a solid, that is as ice. That is not allotropy, because the different forms are not the same states. One is gaseous, one is solid, one is liquid. But when we talk about the same state, that means solid, 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 and the two or the three forms are not are the same element. That is allotropy. So carbon has allotropy. It has allotropes. And from discovery so far, carbon has about 4 main allotropes, which are crystalline in nature. That means they can be they form crystals. They have structure. 4 crystalline allotropes, and they include diamond, graphite, fullerene, and graphene. These are the 4 main allotropes of carbon. The first 2 are the most common, diamond and graphite. I believe you all know diamond, very precious. It has many uses. And graphite is also there, soft, and you can imagine the 2 of them are the same. Diamond, very precious. Graphite, used for maybe pencil, bicycle. The 2 of them, carbon. Then we can also talk about the non-crystalline allotropes of carbon. By the word non-crystalline, we mean they don't have structure as the crystalline carbon. So the non-crystalline allotropes, which are also forms of carbon, include coal, coke, charcoal, lamp black, sugar charcoal, animal charcoal. They are non-crystalline. All of them are forms of carbon. Now let's focus on the main allotropes of carbon, most especially the 2 most common, diamond and graphite. Now let's start with diamond. Diamond is the purest form of carbon. Underline that. Is the purest form of carbon. It occurs naturally as a colorless, lossless solid, which can be transformed into brilliant gems, and it has octahedral shapes. This is the crystalline structure of diamond. Those black dots that you can see are the atoms of carbon. But they are linked together to one another. So this is the structure of diamond. Let's consider the properties of diamond. Like we have said, it is colorless and transparent. It sparkles when it is cut or polished. I don't know how many of us have seen diamond before, but if I thought you have not seen it, you might have watched a movie or thereabout, something like that on diamond. Then it is octahedral in shape, like we saw in the other slide. Then it has a density of 3.5 grams per cm3. That's the density of diamond. Diamond is the hardest known substance. Is the hardest known substance. Only diamond can cut a diamond. Just that. No other substance can cut it. It's the hardest known substance. Then diamond does not conduct electricity. Now, the main reason why it does not conduct electricity is because all the electrons of the carbon are used in forming bonds with another carbon atom. So there is no free electrons. As we will see later, graphite, which is also a form of carbon, can conduct electricity. We will get to that later. But just know that diamond does not conduct electricity. And the reason is because it has no free electrons. Then it is chemically very inert. When we say very inert, hardly will it react chemically. But then it can burn in air. That means it can burn in oxygen at a very high temperature of about 900 degrees Celsius to produce carbon dioxide. Can you imagine that? Carbon dioxide that we breathe out. When you burn diamond, that precious diamond, in oxygen at this temperature, carbon dioxide will be produced. Now let's look at the uses of diamond. I believe you will know and agree that diamond is used as jewelry because of its high refractive index that gives it a sparkling brilliance when it is cut or polished. You see it, those that can afford it, they use it as jewelries, all over. You can't just see it with common people. Then two, it is used industrially in drills for mining and as abrasive to sharpen very hard tools. It's very hard, so you can drill rocks, can be used to sharpen hard tools. Then it is used for cutting glass and metals. Then number 4, diamond is used as pivot supports in precision instruments and as dies for drawing wires. Diamond has a lot of uses that we can just look at later on, probably if we will have the opportunity. But then you can as well, on your own, research, Google it up and see other uses of diamond. Now let's go to graphite, the second most common allotrope of carbon. Graphite is opaque. It is black and it's a solid. It's an opaque black solid. Unlike diamond is transparent, but graphite is opaque. You cannot see through graphite. Yet, the two of them are the same element, carbon. Naturally, graphite occurs at Plumbago. Then, the atoms of graphite form flat layers that are arranged in parallel, one above the other, as you can see in the structure below. That is graphite. They form flat layers. Now let's look at the properties of graphite. The first that should come to mind is that it is a black opaque solid with a metallic luster. Then it is hexagonal in shape. Then it is one of the softest minerals. Can you just look at the differences between the two of them? Because you can be asked to give differences between the two main allotropes. You can see one is transparent, one is opaque, one is octahedral in shape, one is hexagonal. This is hexagonal. One is the hardest known substance. Graphite is what? One of the softest minerals. Then it is a good conductor of electricity. Can you also see that? In contrast to diamond, diamond does not conduct, but graphite does. And the reason why graphite can conduct electricity is because it has a free electrons that is not used for bonding. So out of the 4 electrons in the outermost shell, one is free to move about. And that is what makes graphite to conduct electricity. If you have been able to open that Tiger battery, you see one black rod inside. That is graphite. Then it has a density of 2.3 grams per cm cube. Then it is more reactive than diamond. It burns in air at about 700 degrees Celsius to form carbon oxide. Don't forget, diamond will do that at 900 degrees Celsius. About 900 degrees Celsius. Then, graphite reacts with oxidizing agents to form oxides and also combine with fluorine and tetraoxosulfate 6 acid. So we have a lot of differences between the two main allotropes of carbon. Then let's look at the uses of graphite. Graphite is an excellent lubricant because its layers slide over one another easily. Yes, they slide over each other, so it can be used as a lubricant to prevent friction in machines. It is used in bicycle chains and for the bearings of some motor cars. Then it is also mixed with oil to form high temperature lubricants. You can see lubricants appearing again. Then it is used as electrodes in electroplating and in dry cells. Yes, that's the Tiger battery I mentioned earlier. In dry cells, the graphite is used as the electrodes to conduct electricity. Then it is used to line crucibles used for making high-grade steel and other alloys. Then, I know this will surprise you. A mixture of graphite and clay is used as lead in pencils. So if you have a pencil with you, just try to look at it. Graphite is there, that lead inside your pencil. Then it is also used as a black pigment in paints. Graphite is also used as a moderator in atomic piles. These are the uses of graphite. And I want to believe that you understand what we've said so far about the allotropes of carbon. Now, I want you to write your note, and then you will do the class work / assignment that will be posted to you. Ensure you submit on time. Don't join the lazy ones that are not doing their work on time. Thanks for listening. Have a very good day.